Hello class, this is Professor Maney and I'm making another YouTube video, and this particular one is about the empirical rule. So when you did that, if you had some trouble with it, I'm trying to get some things clarified for you. I know you've already had your test on that, but I know you do have to take the midterm, and the midterm is cumulative. And so I just wanted to make sure you really understood what the empirical rule says. So I took one of your examples out of the book, and by the end of this demonstration, you should really understand what the empirical rule says. Okay, so the empirical rule is a rule describing normal distributions. If you have a normal distribution, the empirical rule and the normal distribution, those two words go together. Because if you have a normal distribution, the empirical rule guarantees that there are going to be certain things true about that distribution. These percentages over here don't ever change. The 68% that you saw when you were studying this, that number never changes. This 95%, that number never changes. This 99.7%, that number never changes. The numbers that change for a particular problem would be your mean and your standard deviation. Those would be the only numbers that would change for a particular problem. We're going to work out an example here so you can see where all these numbers are coming from. And then we're going to look at the graph. By the time we get to that, everything should make a lot of sense, especially if you had trouble with this. So what the empirical rule says is that if you have a normal distribution, 68% of the distribution will be between your mean, take away your standard deviation, and your mean plus your standard deviation. So let's say you had a problem where your mean is 100 and your standard deviation is 14. You would take your mean, take away your standard deviation, that would give you 86. And you would take your mean plus your standard deviation, which would be 100 plus 14 in this particular example that I'm doing. And that would give you 114. So let's see how that affects your graph down here. Notice that I've got the mean is in the middle of the graph, that's 100. And I have, how did I get 34% and 34%? Well, isn't that interesting? 34 plus 34 makes up this 68. So we're saying that if we have 100 in the middle, 34% plus 34%, which makes up the 68%, would have to be between 86 and 114. Where did we get 86 and 114? Back up here when we did these computations. Now remember, this number never changes, so the 34 is never going to change. Only thing that's going to change in a particular problem is the mean, whatever your mean is for that problem, and when you compute one standard deviation above and below the mean, these numbers are going to change. Okay, now let's go to the next step. The empirical rule, the second thing the empirical rule says is that 95% of your distribution, guaranteed, that number never changes, will be between the mean, take away 2 standard deviations, and the mean plus 2 standard deviations. So let's compute that for this particular example. So my mean was 100, take away 2 standard deviations, and when you compute that, you get 72, and 100 plus 2 standard deviations, and when you compute that for this problem, you get 128. So what happens to this 72 and this 128? Well, let's go back down here to the curve. Notice, now I was looking at 86 and 114, but now I'm going down to 72 and I'm going up to 128. So when I go from 72 to 128, I'm supposed to be representing 95% of the distribution. Well, you already had 68% in here. So how are we coming up with 13.5 and 13.5? Well, if you'll take the 68% away from your 95%, that gives you 27%. And if you take half of 27, you get 13.5 and 13.5. So these numbers never change. This 34 stays. This 13.5 does not ever change for a problem. But what is different for every problem is the mean, the standard deviation away from the mean, and then 2 standard deviations away from the mean. All right, now let's go to our next thing that the empirical rule guarantees. The third thing the empirical rule guarantees is that 99.7% of your distribution will be between the mean take away 3 standard deviations and the mean plus 3 standard deviations. Okay, for this particular example, that would be 100 minus 3 times 14, which would give me 58, and 100 plus 3 times 14, which would give me 142. Now let's go back over our graph. So now I've gone below 72 down to 58, and I've gone up to 142. And when I go from 58 to 142, I'm supposed to be representing 99.7% of this entire distribution. Now notice before that we had 95% that was being represented. So if you take your 95 away from the 99.7 that you're now trying to represent, you get 4.7. If you split 4.7 in half, you would create 2.35 and 2.35% of your distribution. So these numbers do not ever change. So once you do this and you see where we're going with this, these numbers don't change, these numbers don't change, these numbers don't ever change, even for a different problem. The only numbers that change for a different problem are the numbers that we've got down here at the bottom. Okay, so right now we've gone from 58 to 142 down here. So there's not much left. We have represented 99.7% of our distribution when we go from 58 to 142. Well, there's not much left, because if you take 99.7 away from 100, that leaves 0.3 is the only thing left. And if you have 0.3, which is 0.30, you get 0.15% and 0.15%, which are these little tails right here. So the only thing left over, and they didn't even ask us to figure those numbers, but that would create, if you went now and added up all these numbers that never change, that would equal 100% of the normal distribution. And of course, then once you get this drawn and you get your numbers down here, you can answer any question that they might have that they would ask you, because you've done the entire problem and you know where everything is. And so now you'll be able to answer any question they ask you about that particular problem using the empirical rule for a normal distribution. So I hope this helps. I'm going to post this on YouTube. If you're having any trouble with it, take a look at it. You may need to look at it more than once to see if it's making sense. And let me know if this helped. Thank you. Talk to you later. Bye-bye.